So when you're deciding whether or not a number is considered significant, there are some rules you can follow. And the rules are a little complicated, not too bad. But let's start with the simplest one. Any non-zero integer is significant. Okay, so if I have a number like 2.6, 2.6 has two significant figures. I'll abbreviate that as sig figs. So two significant figures, that's for the 2 and the 6. Neither 2 nor 6 is 0. They're non-zero integers, so they both count. They're both significant. Another example, 478.15. Okay, how about that? Well, 1, 2, 3, 4, 5 sig figs. There are no zeros there, so they're all significant. Okay, so that one was pretty easy. Let's look at rule number 2. Leading zeros are not significant. Well, what's a leading zero? Let me go with an example here. 0.000023. So these zeros here, those are leading zeros. They're in the front. These zeros right here are not significant. Not sig figs. Okay, so this number would have two significant figures. What about a number like this, 0.0103? Okay, well these first two zeros here are not significant. Those are leading zeros, not sig figs. But the 1 is a non-zero integer, the 3 is a non-zero integer. What about that 0 in the middle? Well, it turns out that there's a rule for that. That's rule number 3. Captive zeros are significant. A captive zero is one that's sandwiched in between non-zero numbers. So that number that we saw before, 0.0103, that 0 is significant. So I would say that this has 3 sig figs. Okay, another example. How about 1004.2? Okay, well, these zeros are sandwiched in between non-zero numbers, the 1 and the 4, so they count. They're significant figures. So in total, we have 1, 2, 3, 4, 5 sig figs here. Okay, one more example. How about 0.060008? Okay, so again, these 3 zeros right here, those are captive zeros. They count. These 2 zeros out front here are leading zeros. They don't count. So this has 1, 2, 3, 4, 5 sig figs. Great. All right. Rule number 4. And this is the hardest rule to understand here, partly because there's a little bit of ambiguity here. Trailing zeros are sometimes significant. All right, well, what does that mean? Well, if there is a decimal point in the number, then trailing zeros are most definitely significant. In other words, if I had a number like 700.00, so there is a decimal point. These zeros are trailing zeros. They're after any other numbers. So they count because there is a decimal point. So I would say that this has 1, 2, 3, 4, 5 sig figs. Okay, so that makes sense. The rule that's kind of hard to understand is if the number does not contain a decimal point, then what do? Okay, so there's a couple different conventions here. So if we have a number like 300, no decimal point, how many sig figs would that have? Some textbooks might say that these zeros count, and they would say this has 3 sig figs. Well, other textbooks would say if there's no decimal point, then you don't count those zeros, and this would have 1 sig fig. Whatever rule you use really depends on what convention you're using. You also might be able to tell from context whether or not these zeros should be counted as significant or not. In other words, if you know the measurement that's attached to that 300, like where did it come from, and you know whether or not it can be precise enough that those zeros should count as significant figures, and you can go ahead and count them. But for this one, it's kind of hard to say for sure how many significant figures there are. So this is the only rule that's a little bit tricky. But If I do have a number like 400 and I put a little dot there, a decimal point, well, that falls under this first part here. If there is a decimal point, the zeros are significant. So I would say that has 3 sig figs. Those zeros there are definitely significant because of the decimal point. For the 300, well, I don't know. It depends on the convention you're using or from context if you happen to know something else about the measurement.